So in the last class we saw that amino acids are crystalline substances. Amino acids are crystalline in nature. Okay, amino acids, most of the amino acids are soluble in water, freely soluble in water. Few amino acids are partially soluble, but most of the amino acids are freely soluble in water. Amino acids are colorless substances. They are colorless. Okay, they are colorless substances, and they have very high melting point. They have a high melting point compared to normal carboxylic acid, compared to normal carboxylic acid and normal amines. Okay, if you compare carboxylic acid, if you compare normal amines, okay, carboxylic acids have high melting point compared to these two. Okay, what's the reason? What's the reason for high melting point? The reason is, in the solid state, okay, amino acid molecules exist as zwitter ions. Okay, amino acid molecules exist as zwitter ions. Exist as zwitter ions even in the solid state. In the solid state. That's the reason why they have high melting point. Okay, right? So these are all the essential points that we discussed in the last class. Now what I'm going to do, I'm going to introduce a term called isoelectric point. Isoelectric point, which we normally represent as small p, then put capital I. Isoelectric point, which is represented like this. Okay, now what is mean by isoelectric point? Students, observe carefully. Let me take neutral amino acid for this discussion. Neutral amino acid. What is mean by neutral amino acid? Neutral amino acid means it contains one acid group, one COOH group, and one amino group. Okay, what is neutral amino acid? If amino acid contain one COOH group and one amino group, we call those amino acids as neutral amino acids. What is meant by basic amino acid then? Basic amino acid means if amino acid contain more number of amino group compared to acid group. Okay, if number of amino group, let me write here. See what is meant by basic amino acid. Basic amino acid means number of amino group, NH2 group, number of amino group is greater compared to number of acid group. Suppose if amino acid contain one COH group and if amino group present two or more, we call those amino acids as basic amino acids. Okay, what is acidic amino acid? Acidic amino acid, very simple. If number of NH2 group and number of COOH group, okay, if you compare the number of an amino acid, if acid group is more in number, we call those amino acids as acidic amino acids. Okay, last class I have told you that we have basic amino acid, we have acidic amino acids, right? Let me just give at least one or two examples for basic and acidic amino acids. Just I'll show you. Last class we discussed all the structures. Yeah, say this. lysine is an example where this R group contain one amino group. See, right? This is connected to an alpha carbon. You know very well. This R group is connected to an alpha carbon. That alpha carbon contain one amino group, one acid group already. This is the usual structure of amino acid. Okay. Now this R group also contain one more NH2. So if you count the number of NH2 group, I have two NH2 group and one acid group. Which one is more in number? Students? I have two NH2 group and one acid group. Which is more in number? Amino group or acid group? So amino groups are more in number. Therefore, lysine is a basic amino acid. Lysine, okay, is a basic amino acid. I'll give an example. Example is lysine. Similarly, acidic amino acid. See the structure of aspartic acid, glutamic acid. So here I have given. In the aspartic acid, see this is the R group. This R group is connected to the alpha carbon C, which is already contain one H, one NH2 group and one acid group. One acid group is there. Now see, here I have an acid group, here I have another acid group. We have two acid group and one amino group. So in this case, number of acid group is more compared to amino. Therefore, this amino acid, aspartic acid, is an acidic amino acid. Similarly, glutamic acid also contain one extra acid group. Therefore, this is also an acidic amino acid. Okay. So, for acidic amino acid, example is aspartic acid. Aspartic acid. Okay. And glutamic acid. So, keep this in mind. What is the meaning for neutral amino acid, basic amino acid and acidic amino acid? Okay. Now in order to understand isoelectric point, what I'm going to do, I'm going to choose neutral amino acid first. Okay, we'll understand what is the meaning for isoelectric point. Then we'll go and discuss about the other amino acids. Okay, and how to calculate the isoelectric point also we'll discuss. Okay, now students, observe this carefully. Amino acid usually exists as deuterion. I have told you. Okay, so let me just write the deuterionic form like this. Z COO minus. This is some amino acid. I'm going to take neutral amino acid just for understanding purpose. So neutral amino acid contain one amino group, one acid group, but exists in deuterionic form. Okay, observe this carefully. Students, suppose if I put this amino acid in acidic solution. Okay, acidic means pH is low. Suppose if I add amino acid in solution containing solution of low pH. Right, low pH means acidic, right? Low pH means acidic medium. Low pH means acidic medium. In acidic medium, see, low pH means we are having lot of H plus. That's the meaning, right? Low pH means we are having lot of H plus. So what will happen? This H plus combine with the COO minus and form and become, the amino acid will become like this. Students, observe carefully. This is the new, in this structure, we have one positive charge, one negative charge. So what is the net charge? What is the net charge? Net charge is 0. We call this ion as dipolar ion. Dipolar ion. Okay. So dipolar ion, okay, carry net charge of 0. Right. Net charge equal to 0. Right. Now in low pH, if we add amino acid in solution containing acidic or in acidic medium, if I add amino acid in acidic medium in low pH, what will happen? This COO minus group takes H plus and become COOH. So in acidic medium, amino acid exists like this. Now what is the charge on the amino acid? Students, what is the charge now? It carry positive charge, right? So now the amino acid carry positive charge, so it will move towards cathode, right? It move towards cathode, right? Because cathode is negative, you know very well. It will move towards cathode. What is the meaning? Suppose you take amino acid, right? Okay, you take amino acid in acidic solution. So I have some amino acid and the solution is acidic. I'll place two electrodes. I'll connect one to the negative terminal of the battery and the other to the positive terminal. The small line indicate negative and the larger one indicate positive terminal. Okay. In acidic medium, amino acids move towards cathode. Okay. Students, are you able to follow this? Why amino acid move towards cathode in acidic medium? Students, can anyone give explanation for this? Why amino acid molecules move towards cathode in acidic medium? Presence of positive charge. In acidic medium, amino acid molecule carry net positive charge. Therefore, they move towards cathode. Okay. Now, suppose if I add amino acid in basic medium, means high pH. pH above 7, right? 8, pH 8, 9, 10, like that. If I go to high pH, what will happen? High pH means OH minus ion will be in more number. Students, basic medium means solution contain more OH minus ions. What OH minus ion will do? It will remove H plus. It will remove H plus from this NH3 plus group. So if it remove H plus, what will happen? This become NH2. This will become NH2 ZCOO minus. Now the ion become an anion. Okay, you have net negative charge now. Now tell me, this amino acid molecule, right, or amino acid molecule in basic medium, right, move towards which electrode? Which electrode these ions will move now? They carry net negative charge. Yes, students? Yeah, since they carry net negative charge, these ions move towards anode. So keep this in mind. In acidic medium, that is under low pH, right, under low pH, the zwitter ion or dipolar ion will become like will become a positively charged ion. Since it is positive charge, it will move towards cathode. Whereas in basic medium means high pH. In high pH, that zwitter ion will become a negatively charged ion and it will move towards anode. Okay, so keep this in mind. At low pH, it will move towards cathode, and at high pH, it will move towards anode. This is a well-known concept. Listen, at one particular pH, in between, right, instead of low pH and high pH, if I take some intermediate pH, at one particular intermediate pH, okay, amino acid molecule neither move towards cathode nor towards anode. That pH is what we call as isoelectric point. Okay, so what is isoelectric point? Let me write here. So what is meant by isoelectric point? So isoelectric point is the definition: the pH at which amino acid molecules neither move towards cathode nor towards anode. The pH at which amino acid molecules neither move towards cathode nor towards anode is called the isoelectric point. Is called the isoelectric point of the amino acid. It's called the isoelectric point of the amino acid. Okay. Now, what is the meaning for that? What is the meaning? Okay, let me write here. And how to find the isoelectric point. Students, observe carefully. At low pH, amino acid molecules, I have told you, at low pH, when pH is low, amino acid molecule carry net positive charge, so they move towards cathode. Whereas at high pH, amino acid molecules carry net negative charge, so they move towards anode. But in the intermediate pH, okay, at one particular pH, between low and high, at one particular pH, right, amino acid molecule neither move towards cathode nor towards anode. That pH is what we call as isoelectric point. Okay, now listen. So how to calculate this? Suppose I will take the deuterionic form of amino acid first. Students, observe carefully. I will take a deuterionic form, right? If I add H plus, okay, what will happen? It will become conjugate acid. Okay, so let me add H plus here. If I add H plus, it will become, that is in low pH, right? Low pH. I'll put this line shorter and this line longer. It has meaning. Okay, you have to write like this only. What will happen? Listen, this NH3 plus remains as such, and COO minus takes this H plus and becomes COOH. I have told you. Students, observe carefully. To any molecule, if you add H plus, if the molecule takes that H plus and become an ion, okay, we call this species as the conjugate acid of this ion. We call this species as conjugate acid. So this is conjugate acid. So let me write this as this ion simply as Ca, conjugate acid, Ca. Okay, now what happens at high pH? Right, at high pH, okay, at high pH means we should remove H plus, right? We should remove H plus. So at high pH, this H plus from NH3 plus will be removed, and you will get this ion NH2 Z COO minus. Okay, listen, students, from any molecule, if you remove one H plus, you will get a species called conjugate base. It's a basic terms that I am using here. Conjugate base. What is conjugate acid? What is conjugate base? Very simple. To a molecule, if you add H plus, you will get a new species. That new species is called conjugate acid. From a molecule, if you remove one H plus, you will get a new species. That new species is called conjugate base. Okay, let me represent this simply as Cb. This is conjugate base and this is conjugate acid. And this is dipolar ion. I'll write this as Dp, dipolar ion or deuterion. Okay, students, observe carefully. At the isoelectric point, what actually happens? At isoelectric point, this dipolar ion concentration, dp concentration, let me write in the square bracket, that concentration of dp becomes very high, If this concentration becomes high, this ion carry net charge as 0. This ion carry net charge as 0, so they neither move towards cathode nor towards anode. So if the solution contain dipolar ion concentration is high, definitely never move towards cathode or anode. And one more thing, at the isoelectric point, the conjugate base and conjugate acid should have same concentration. Okay, conjugate acid concentration and conjugate base concentration should be equal, because if they are equal, right, then the ions, right, and they are equal but very low, therefore net movement is 0. Okay, because these ion carry positive charge, they move towards cathode. These ion carry negative charge, they move towards anode. Since same concentrations are there, so number of molecules moving towards cathode and anode are almost equal, and we can say they are negligible. We can neglect, right? So net movement is 0. We can say like that. Okay, so keep this in mind. At isoelectric point, dipolar ion concentration will become very high, and the concentration of conjugate acid and conjugate base become equal, okay, and they are very low. Now, keeping this in mind, I am going to calculate the isoelectric point. How to calculate? Okay, let me write this as, students, observe carefully. First I will take this one. See, this is the Zutter ion, dipolar ion dp. Okay, dp in the presence of H plus, okay, that is in acidic medium, it takes H plus and form this ion and this ion, okay, cation. Now here you are having an equilibrium, therefore how to calculate equilibrium constant for this? Let me take the equilibrium constant for this reaction as K1 or Ka1. Ka1 is the equilibrium constant for this reaction. Okay, so what is Ka1? Ka1 equal to concentration of this ion, this is conjugate acid, so concentration of conjugate acid divided by concentration of dipolar ion dp and concentration of H plus. Okay, now what is the concentration of Ca from this? Concentration of Ca is equal to, okay, once again, okay, actually I have to write in a reverse manner, so that you'll get K1 for this acid. Okay, I'm sorry, I made a mistake. I have to write in the reverse manner. So NH3 plus Z COOH. I will take this conjugate acid. This is conjugate acid. This conjugate acid will dissociate and become NH3 plus Z COO minus and H plus. Okay, I'm just writing the in the reverse manner so that you will get Ka1 for this conjugate acid. Ka1 is the equilibrium constant for this conjugate acid. Okay, and what is the equilibrium constant value? Ka1 equal to concentration of the dipolar ion into concentration of this H plus over concentration of conjugate acid Ca. Therefore Ca is equal to, from this, concentration of the conjugate acid equal to, okay, I will bring this Ca here and Ka1 here. I'll get concentration of dP by into concentration of H plus by Ka1. Students, observe this carefully. Isoelectric point is very, very important for your competitive examination. Okay, I'm just showing you how to get the final formula. Anyway, final formula is very important, but you must know how to get that. So from this we found the concentration of conjugate acid. Let me take this as equation number 1. So we have found what is the, we have taken conjugate acid and how conjugate acid dissociate, and from this we have found the concentration of conjugate acid. Now I'll take the conjugate base and let me show you the Ka2. Okay, so the conjugate base is this NH2 ZCOO minus. For this I'll take NH3 plus, because we need to find out this K, okay, K of this particular group. So this will dissociate and gives you NH2 ZCOO minus, okay, and release 1H plus, right? So this reaction will give you the Ka value of this particular group. The previous one will give you Ka value for this acid COH group, and this will give you the Ka value for this NH3 plus group. I will take this Ka as Ka2, okay, and from this what is Ka2? Ka2 equal to concentration of this conjugate base. This is the conjugate base, concentration of conjugate base into concentration of H plus by concentration of the dipolar ion, okay, and from this the concentration of conjugate base can be given as Ka2 into concentration of dipolar ion over concentration of H plus. Students, is this clear? Any doubt? Any doubt, students? I have taken conjugate acid and I wrote the I found Ca, concentration of Ca, and I took this deuterionic form, and I found if this NH3 plus undergoes ionization, then this equilibrium gives you Ka2. Ka2 will give you equilibrium constant for ionization of NH3 plus. Ka1 corresponds to the equilibrium constant for the ionization of COH group. If COH group ionizes, you will get Ka1. If NH3 group ionizes, you will get Ka2. Okay, now what I am going to do, I am going to equate these two, because you know you are at the isoelectric point, concentration of Ca and Cb are equal. See, at the isoelectric point, concentration of Ca should be equal to concentration of Cb. Therefore, if I equate these two, okay, concentration of C in equation 1, concentration of Ca is concentration of dipolar ion, concentration of H plus over Ka1 equal to conjugate base concentration Ka2 into concentration of dipolar ion by H plus. Okay, I'll bring H plus here and I'll bring all other terms to the right hand side. So I'll get H plus squared, H plus into H plus become H plus squared equal to, I'll bring this term here, so I'll get Ka1 into Ka2. Okay, this dipolar ion concentration get cancelled because they are actually same in the solution. So I cancelled it. So now H plus square equal to Ka1 into Ka2. This is the only relation we have now. I'll take logarithm both sides. Students, if you find any difficulty, you please tell me. Okay. I'll take logarithm both sides. If I take logarithm, I'll get 2 into log base 10 concentration of H plus. If I take log, that power will come in front. It's a logarithmic rule. So 2 into log H plus. And here if I take logarithm of A and logarithm of into b, a into b can be written as log a log Ka1 plus log based on Ka2. Okay, now I'll multiply by minus 1 both sides. So 2 into minus log of base 10 concentration of H plus minus log of base 10 Ka1 minus log of base 10 Ka2. Okay, students, observe this carefully. This is nothing but pH. So 2 into pH equal to, this is nothing but pKa1, and this is nothing but pKa2. So what is pH? pH equal to pKa1 plus pKa2 by 2. Yes, we have found the final formula. Student, keep this in mind. This pH is actually called the isoelectric point. So what is isoelectric point? If you want isoelectric point for a neutral amino acid, you take the pKa1 value and pKa2 value, students, observe carefully, and divide that value, add them, then divide the value by 2, you will get the isoelectric point. This formula is very useful for your competitive examination. For neutral amino acid, students, observe carefully, for neutral amino acid, you take the value of pKa1 and pKa2, add the 2 value, divide the value by 2, that's all. You will get the isoelectric point. Okay, what is isoelectric point, student? What is isoelectric point? For NCERT, this derivation is not important, but this final expression is very important for the competitive examinations. Okay, so keep this in mind. This is the isoelectric point. Isoelectric point is nothing but pKa1 plus pKa2 by 2. This is the formula applicable for neutral amino acids. Now, what about the other amino acid, basic or acidic? Right, basic amino acid and acidic amino acid. What to do? Right, suppose an amino acid, right, I have an amino acid which contain 2 NH2 group and 1 acid group. What type of amino acid is this? Basic amino acid. Okay, for basic amino acid, students, observe carefully. For acid, they will give a Ka value, Ka1. For the 2 basic group, they will give Ka value, so Ka2, Ka3. Observe carefully. You take the values of the amino groups, because which is more in number. Okay, what you have to do, if basic amino acid given, okay, you take the value Ka value for the amino groups, right, and find the pKa value. So pKa2 plus pKa3, these two corresponds to amino group. Okay, and add them, divide the value by 2, you will get what is called the isoelectric point. This is for basic amino acid. You have to do like this. For neutral amino acid, you should take pKa1 for the COH group, pKa2 for the amino group. Okay, whereas for basic amino acids, right, you have to calculate the Ka2 and Ka3 of the amino group and find the pKa values, okay, and add them, divide the value by 2. For acidic amino acid, this is for basic amino acid. Suppose if we take an acidic amino acid, what is acidic amino acid? It contains 2 COH group, and 1 amino group, like aspartic acid or glutamic acid, etc. Right, now we have acid groups more in number. So for one acid group, I'll give the value as Ka1. For other acid group, I'll give the value as Ka2, and amino group Ka3. In this case, which is more in number? Acid group. Add the values of the acid group. So find the pKa1, find the pKa2, add the two value and divide the value by 2, you will get what is called the isoelectric point. If you are preparing for competitive examination, then this is very, very useful. Okay, very, very useful. Take down. Is it clear, student? Any doubt? Is this clear? I'll give one problem so that you can understand what's the meaning for this, how to proceed if problems comes with this. Yeah, just I'll show you one or two problems will do. I'll take an amino acid, say glycine, simplest amino acid, glycine. Students, observe this carefully. Glycine is a neutral amino acid. You must, but in the question itself they'll give it clearly. But now for problem solving purpose, I'll take this. Glycine. For glycine, the acid group, alpha amino acid group. For this, the pKa1 value, I'll give pKa1 value is 2.3. And amino group, alpha amino group actually become amino NH3 plus ion. For this, let the pKa value, let me represent this as pKa2. pKa2 value is 9.6. Can you tell me what's the isoelectric point, students? This is a neutral amino acid. For neutral amino acid, pKa value for acid group, COH group, and pKa value for NH3 group, NH3 plus group alone will be given. To find isoelectric point, just add the two value, divide by 2. That's all. What's the answer?
5.95.
5.95. Okay, yes, that's the isoelectric point. Very simple. Right. Suppose I'll take a basic amino acid. I'll take a basic amino acid. For example, I'll take lysine. In lysine, we have an acid group. Okay, let me give the value as pKa1, and we have two amino group. Alpha NH3 plus group will be there. This is amino group attached to alpha carbon. Okay. For this, let the pKa value is pKa2, and we have one more amino group which is existing as side chain. One more amino group. For this, the pKa value is pKa3. Let me give the values. For lysine, it is 2.1 for acid COH group, 9.0 for NH3 plus group, and 10.5 for NH3. Now, what is the isoelectric point? Basic amino acid means they have two amino group, but amino group I have taken as conjugate acid. Yes, how to find isoelectric point now? Which two value we should consider? Very simple. For basic amino acid, yeah, that's all. Good. You take the amino group values, NH3 plus values. Okay, add them. 10.5 plus 9, then divide the value by 2. What's the answer?
9.7.
9.7. That is the isoelectric point for basic lysine. Lysine is a basic amino acid. Similarly, if I take acidic amino acid, say for example aspartic acid. Okay, aspartic acid, we have alpha amino acid group, alpha COH group, alpha NH3 plus group. Okay, amino group, acid group, these two must present. Okay, apart from that, in the case of acidic amino acid, we have one more COH group in the side chain, right? And pKa value for this is, let me give this as pKa1, and this is pKa2, usual notation, and this is pKa3. Okay, Can you tell me what is isoelectric point now? Don't worry about the formulas. Just see and tell me which pKa values we should consider. For acidic amino acids, yeah, we should consider only COH group values. COH group values, right? Let me give the value for aspartic acid. This is 1.9. This is 3.8. Then this is 9.8. Can you tell me the isoelectric point?
Five 5.85.
5.85, right? That's it. This is how we must do for amino acids. Okay, is it clear, student? Any doubt?
No doubts.
Right, yeah. So this is regarding isoelectric point. Okay, now let me introduce what is called the peptide linkage. Peptide linkage or peptide bond. Peptide bond. What's the meaning for that? Okay. Students, I think I made a mistake. 1 second. Let me check that. I'll come back. I think I made a mistake. Yeah. Students, just a small correction here. See, for basic amino acid, I have told you that you should consider the amino group Ka values, and you should take the pKa and add the two value divided by 2, you will get isoelectric point. Yes, this is correct. For acidic amino acid, students, actually I made a mistake. For acidic amino acid, we should take pKa value, lower pKa value. For basic amino acid, these two will give you always a higher pKa value. Right? Try to understand this carefully. This pKa value and this pKa value will be high, because for basic amino acid, pKa value should be high. These two pKa values are high, so take the higher values, add them, divided by 2 for basic amino acid. For acidic amino acid, you take the lower pKa values. Okay, pKa1, low pKa1 and low pKa2. Add them, divided by 2. Here these two should be high. Okay, you know very well, if you compare COH group and NH3 plus group, this is NH3 plus. If I take NH3 plus, students, observe carefully. I am giving you the same point, but I made a mistake here. That's why I'm just telling this again. See, NH3 plus group, they have high Ka value, pKa value. So take the pKa of this, add the two value, divided by 2. This is correct for basic amino acid. But for acidic amino acid, okay, you should take the lower pKa values. Okay, and then you should add the values, and then you should take the average. So what's the meaning for that? What's the meaning? See, in the case of aspartic acid, that's why I made a mistake here. See, pKa values are given, right? pKa values are given. For acidic amino acid, you should take the lower pKa values. So this is a lower pKa value. Not this one, I'm sorry. This is another lower pKa value. Take the lower pKa value and take the average. Students, are you able to follow this? Okay, I made a mistake. In basic amino acid, take the higher pKa values, add them, divided by 2. For acidic amino acid, take the lower pKa values, add them, divided by 2. Okay, so 1.9, 3.8. Add these two value and divide by 2. How much you'll get? 4.8, 5.7, right? 5.7 divided by 2. Students, is this clear? Are you able to follow? You will get 2.
Yes, sir.
Yeah, you will get 2.8, right? Roughly 2.8. Am I right? This is 5.7 divided by 2, right? 2.8 something you'll get. This is the isoelectric point. Okay, keep this in mind. I made a mistake actually. Right, so let me write this just for clarity purpose. I'll write this separately. Listen, students, so for isoelectric point, this is the formula you should remember for isoelectric point. Number 1, if the acid is neutral amino acid, in the examination, if neutral amino acid is given, right, you can calculate isoelectric point just adding the pKa values for the acid group and pKa value for the NH3 plus group. Add the two value divided by 2. Okay, you need not worry about, because only two groups are there in neutral amino acid. But if you come to basic amino acid, right, pA value equal to, you should take higher pKa values. pKa1 high value, high pKa1, high pKa2. What is meant by that? If, see, for basic amino acid and acidic amino acid, they will give 3 values. Among the 3 values, you choose 2 higher values, higher pKa values. Take higher pKa values and take the average. That will give you the isoelectric point for basic amino acid. For acidic amino acid, you should choose lower pKa values. 3 values will be given. Among the 3, you choose 2 lower pKa values. pKa1 low pKa1 and low pKa2. Why I am saying low? 3 values will be given. Among the 3 values, you choose 2 lower values and take the average. You will get what is called isoelectric point. This is how you must calculate for acidic amino acid. Is it clear, student? Is this clear? Yes, take note. Remember these two, this is very simple one. So now usually in the competitive examination they won't ask this. They will ask this one. So you should be a little careful, right, in doing problem with that. Okay, then now let me go back to the peptide linkage and we'll discuss what is peptide linkage, what is peptide bond, right, and other things. Okay, students, observe carefully. Peptide bond. Listen, peptide linkage. I'll take suppose I'll take two amino acids. Say I have alpha carbon, COH, NH2, H, and here I'll put some R group. Say let me represent this as R1. This is one amino acid. Okay. You can also write COH. Okay, let me write that. Plus, I'll take another amino acid. It may be same or may be different. Just for understanding purpose, I'll take this as R2. It's a different amino acid. Okay, I'm taking two amino acids. Now, what I'm going to do, listen, this is an acid group, this is a basic group. You know very well, acid and base react and eliminate a water molecule. So, you remove a water molecule from this, and what we'll get is NH2 C R1 H. Now here I'll keep this CO group as such. Remove this OH and remove one hydrogen here, So you'll get water and you'll get a new bond between this carbon and this nitrogen. Keep other groups as such. Okay, we have taken two amino acids, the two amino acids reacts, eliminate a water molecule, you will get a new compound. This is also amino acid, but in between we have an amide linkage. Okay, amide linkage, and this linkage is what we call as peptide linkage. Students, observe carefully. CONH linkage is what we call as peptide linkage. Right? And here, how many amino acids are there? How many amino acids we have combined? Correct. We have taken two amino acids. No? We have taken two amino acids. We have formed a new compound, right? So this amino acid has actually two amino acid units. Or this compound has two amino acid units. So it is called a dipeptide. Dipeptide. Students, be careful in this. I have one peptide linkage. Okay, CONH linkage is called peptide linkage. I have only one peptide linkage, but there are two amino acids combined and form this compound. Therefore, it is called dipeptide. So dipeptide refers to number of amino acid group. Number of amino acid group, not number of linkage. Okay, so dipeptide means if there are two amino acids forms a compound, it is called dipeptide. If three amino acids combine, you will get tripeptide. If four amino acids combine, you will get tetrapeptide. Okay, take note. So what I am trying to say here is dipeptide means dipeptide. What's the meaning? It consists of two amino acid units. Two amino acid units, and one consists of one linkage, one peptide linkage. One peptide linkage. That's a dipeptide. Okay. If you take a tripeptide, let me write the next page. If I take a tripeptide, what is meant by tripeptide? Tripeptide is a compound contains three amino acid units. Tripeptide means three amino acid units should be there, and there should be two peptide linkage. Two peptide linkage. Okay. Now the question is this: octapeptide. You try to tell me how many amino acids, how many linkages are there in an octapeptide. In an octapeptide, yes?
8 amino acids.
Very good. 8 amino acids. How many linkage?
7.
Well done. That's all. That's all. Good. 8 minus 1. That's all. 7 linkages should be there. Okay. Take note. And keep this in mind, student. In carbohydrate chemistry, two monosaccharides are connected through ether linkage, and that linkage is called glycosidic linkage. Okay. Glycosidic linkage. I'm just making you to remember this point. Two monosaccharides are connected through glycosidic linkage, whereas in protein chemistry, two amino acids, one amino acid and another amino acid, two amino acids are connected through a peptide linkage, CONH. It is called a peptide linkage. Peptide linkage. Okay, don't forget this. In carbohydrate, two monosaccharides are connected by glycosidic linkage, whereas in peptides, right, in polypeptides or proteins, two amino acids are connected through amide. This linkage is called peptide linkage. Okay, it is actually amide, but we call it as peptide linkage. Right? If two amino acids are joined together through an amide linkage, we call that linkage as peptide linkage. Okay, now um, okay, so now we know what is meant by dipeptide, what is meant by tripeptide, tetrapeptide, etc., etc. Okay, now what's the meaning for polypeptide? What's the meaning for polypeptide? Polypeptide means it consists of more than 10. By just for definition sake, I'm saying, if any polypeptide molecule, when you can call a peptide as polypeptide, if a peptide molecule, peptide means chain, contain more than 10 amino acid units, okay, more than 10 amino acid units. If any polypeptide chain or any peptide chain contain more than 10 amino acid units, we call those peptide chains as polypeptide. Remember, usually polypeptides contain 100 or 1000 or 2000, okay, amino acid units. For definition sake, I am giving this point, but usually polypeptide contain more number of amino acid units. Okay, so if many amino acid units join together by peptide linkage, you will get what is called polypeptide, right? A single polypeptide chain, right, can form or can exist as a protein, or sometimes two or more polypeptide chain join together and exist as a protein. Students, observe carefully. A single polypeptide, see polypeptide, you can write this as some kind of chain which consists of many amino acid unit, okay, amino acid unit, many amino acid units, right, join together and form what is called the polypeptide chain, right? In polypeptide chain, if a single polypeptide chain forms a protein, okay, sometime a single polypeptide chain can form a protein, sometime many polypeptide chains join together and form what is called protein. So protein may be a single polypeptide chain. Protein may also be may also contain many polypeptide chains together. Okay, it depends upon the protein, right? So keep this in mind. It's very important. What is meant by a protein? Usually proteins are polypeptide chains which contain almost all 20 amino acids. If polypeptide chain contains all 20 amino acid units, we call them as proteins in general. Okay, protein can be a single polypeptide chain. Protein can be can consist of many polypeptide chains together. It can exist like this also. Okay, so keep this in mind. This is a very important point, right? Then, so now you know what is meant by protein. Proteins are, what are proteins? Proteins are polypeptides. Polypeptides, okay, maybe a single chain or multiple chains. Okay, proteins are polypeptides containing all 20 different amino acid units. Containing almost all 20 different amino acid units. Proteins are polypeptides containing almost all 20 different amino acid units. Is it clear, student? Any doubt? Okay, yeah, so very essential point. Keep this in mind. Now what I'm going to do, what is the structure of protein? Okay, the time is already 5:46, so I stop here. But in the next class we are going to discuss about the structure of protein and what are the different types of proteins are available. Okay, and which proteins are soluble in water, which proteins are insoluble in water, and what are their functions, right? Those things we are going to discuss in the next class, right? Then after that we'll start nucleic acids. So in nucleic acids we have only RNA and DNA. I'm not going to discuss much about that, but I'm going to give you some essential points. Okay, right. I stop here. We'll continue in the next class.